there are different types of iron: pure iron, cast iron, wrought iron, and then there is the alloy of steel. Now, these are very important sources of MCQ questions. Okay. Um, we are often asked about steel. Okay. So what we have to mix with iron to obtain steel? That is most of the time asked. So it is an alloy of chromium is important here, and nickel is important here. Okay. So with iron, we shall be adding chromium and we shall be adding nickel and few others, obviously, as the name is here. And carbon is obviously there in all the types. So it gives us steel. And there are different types of steel depending upon how they are produced, how many percentages of carbon we have added in their production. We have different types of iron. Now these values are again very important. So if it is a pure iron, what is the percentage of carbon? 0. That is one MCQ question. And this is very important. In case of wrought iron, what is the percentage of carbon? And others we can also see, but these are very important. Okay. Low carbon also, let's take. This one is also low. If it is low carbon steel, then the percentage of carbon in that steel is less than 0.25 percentage. Okay. And in this way, the percentage of carbon goes on increasing. And if the percentage of carbon goes on increasing, the ductility will decrease. So what are the properties, okay, with carbon? So if it is low carbon, if it is medium carbon, and it is high carbon, what are those properties? So if it is low carbon, it has excellent ductility and toughness. Then if it is high carbon, it is hard, it is strong, but ductility will reduce. Okay. Okay, so the low carbon where it is used in nuts, bolts, etc. Okay. And the high carbon will be used in cable where we require more ductility. Okay, in those applications it will be used. Okay, so we have to remember what carbon does to the steel, to the iron, and what are the different percentages of some of the important types of iron. Okay, according to the percentage of carbon, what is different types? What is wrought iron? What is low carbon steel? What is the percentage in them? Okay, according to that. And what is pig iron? Okay, it has most number of fraction of carbon in it. So okay, then this one, stainless steel is very important. Alloy of iron and chromium, very important. Okay, percentages we may forget, but this value again is very important. We have to remember this value. It is asked all the time. What is the Young's modulus of steel? 2 into 10 to the power 5 Newton per millimeter square or megapascal. Sometimes it will be called megapascal. If it is megapascal, that is 10 to the power 6 Pascal. What is Pascal? Newton per meter square. Now, if I convert this unit into Newton per millimeter square, it will just be equal to Newton per millimeter square. Okay, 1 Newton per millimeter. So the megapascal is equal to Newton per millimeter square. So Young's modulus of elasticity, we have to remember 2 into 10 to the power 5 Newton per millimeter square or megapascal. Again, this value is, what is the Young's modulus of elasticity of aluminium? It is 1/3 of modulus of elasticity of steel. Okay, fine. So we steel can take more load for the same amount of deformation. Okay, if there is a deformation of 1 millimeter in steel and in aluminium, also the deformation is 1 millimeter, then the steel will be taking 3 times more load. Okay, so another important point, because uh, it is asked that why we do not use aluminium in our buildings. Okay, why we use steel only, why we cannot use aluminium. Okay, it is asked, it is another probable question. So then modulus of elasticity is less, and there is one more thing we will see. That is the reason why aluminium is not used and steel is used. Then density, we have to remember 7850 kg per meter cube, or 78.5 kilonewton per meter cube. So this value, again, we have to remember, not to be forgotten. Modulus of rigidity we can forget. Poisson's ratio we have to remember. The definition of Poisson ratio, I hope we know. Lateral strain divided by longitudinal Poisson's ratio. And this is the most important value in elastic range. It is 0.3. So we will try to remember this value. 0.3 is the Poisson's ratio for steel in elastic range. Okay. When it goes into plastic range, there is more deformation, and then the lateral ratio increases. It becomes 0.5. And also one more thing here, it is often asked, what is the maximum and minimum values of Poisson's ratio? So the maximum value of Poisson's ratio is 0.5. Okay, Poisson's ratio is less than or equal to 0.5. Okay, generally it is 0 to 0.5, but for some materials it can be -1 also. Okay, it can range from -1 to to 0.5. So again, this value, the range of Poisson's ratio, is very important. It is asked in the competitive examination most of the time. Okay, then this formula, delta L is equal to P, delta L is equal to PL by AE. We already know this formula, I hope. Very important formula. Then this one, the thermal coefficient. What is thermal coefficient? It is the occurring in the material corresponding to unit increase in temperature, right? So the thermal coefficient of steel and thermal coefficient of concrete is having the same value. Okay, see, same value. So this is the reason why we use steel in RCC. Why we use steel with concrete to give us RCC. This is the reason, main reason, because they have the same thermal coefficient of expansion. So for a certain degree increase in temperature, the expansion in concrete is the same. So they maintain a condition of linearity, okay, in between them. The amount of expansion is same, so there is no the condition of perfect strain is maintained. When we hope that there is no relative displacement between the rod and the concrete. Okay, then these are some of the important codes. IS 456 we are using already, I hope. IS 800 we shall see. Then pre-stress concrete we have in module 4, this will come. Design mix, it's not in the syllabus, but it is one very important. This code is to be referred while preparing design mixes. Suppose we have to go for M25 grade of concrete, M30 grade of concrete, then what we have to do, we have to do design mix. So the procedure of doing design mix is available in this code IS 10262. Then these codes for fine and coarse aggregate, what tests are to be done in fine and coarse aggregate, what zoning they will fall on according to their size given in IS 383. And IS 87 is important design of load for buildings and structures. Now you are studying RCC, you are designing slab, beam, we calculate dead load and imposed load. So you understand what is dead load? Dead load is the fixed load that is its self weight on it. If there is some permanent structure attached to that beam, to that slab, it is going to be dead load. And imposed load is something which is moving, a furniture, a human being, or something like that. These are imposed load, right? Now, this code gives us guidelines according to this wind load, imposed load, how to consider those loads in our building according to the type of the building. If it is a residential building, what will be the imposed load? If it is a commercial building, what will be the imposed load? Okay. If it is a residential building, obviously we are expecting that less people will be there in the building. But if it is a commercial building, we will be expecting that more people will be there, and there will be more furnitures, more items. Therefore, the load will also be more. Okay. So according to the type of building, is it a residential one, commercial one, or public use building, or an university, school? According to that, different types of loadings and criteria and conditions are given code, and this code also gives the conditions to calculate wind load, how to calculate wind load and how to apply it in the structures. So we have to go into that code. Slowly it will come in our, just giving you the information that these are some important codes that we should be looking to. Then we're talking about sections. We have seen I-beam sections in steel section. These are standard steel sections. These are produced in the plant. Now, why we are producing sections like this? Okay. In concrete, we see that we have a beam like this, right? We have a beam like this, and it's done. But in steel, we are producing sections like this. So why we are doing that? We are doing this to provide us economy, because we see here, this is a stress diagram, okay? This is a shear stress diagram, and this is a bending stress diagram. Now, from the bending stress diagram, we see that the bending stress is more. Okay, these are the values of bending stress. The bending stress is more at the end. The bending stress is more at the end. Right? So therefore, to counteract the bending stress, we require more area in the edges, in the top and bottom here. Here we have wider sections because these sections are resisting the bending stress. Okay, fine. Then we see that this is the distribution of shear stress, and we see that shear stress is maximum in the middle portion here. And to counteract shear stress, we require depth. Okay, the width is not that much important. We need more depth. So this is web. So this portion is mainly resisting the shear, and these portions are resisting the bending stress. So by doing so, we are producing economic section that will be beneficial in resisting bending and shear, and also we shall be saving some material. So therefore, we have this type of section in steel structure, but we cannot obtain this type of structure in a concrete beam, right? So in concrete beam, we have one full beam like this. Then these beams are given some standard names, okay, like ISLB, ISMB, ISWB. These type of names are given. Okay, so if it is an ISLB, what is the full form? Indian Standard Light Beam. It is MB, that is M for medium. It is W, it is white. W is for white. Junior beam, and then we have standard heavy beam. So this one can be question of MCQ type of question. Okay, they are asked. We are asked this type of question. We'll be given options and we'll be asked for which type of beam is the heaviest from the following options. So we will be given ISLB, ISMB, ISWB, ISHB. So we have to know that ISHB, the H is there for heavy. So it is the heaviest one among these. Fine. And then if we are asked which one of the following beam is the lighter one, then obviously it is going to be ISLB. So these are probable questions, MCQ type questions in competitive examinations. Okay, and also I hope we know this already, that this part is called flange and this part is called web. Okay. Then we can have angle sections also like this. Okay. Here we have, and then it is in the longitudinal direction, it is going like this. So we have a standard steel table where all these dimensions are mentioned according to the type of section. If it is an angle section, we will be given the angle section and what are the standard available type of sections. Okay, it will be mentioned there. So it is, if it is where is my pointer? Like this, ISA 100 into 100 into 10. So that means this side is 100 mm, this side is 100 mm. Thickness of the plate is 10 mm, 10 mm. Okay. Then this one is unequal angle. So this one, there was equal length here, but this one is of unequal length. So it is written 150 by 100 by 10. That means one side is 150 mm, then other is 100 mm, and this one, the thickness is 10 mm. Okay, this way they are designated. Okay. Then similarly, we will have T section. Okay, wide flange, standard long leg. Okay, so this is it's fine. Then we will have channel section, and the channel section, okay, this is important. If it is mentioned, it means this overall depth of the channel. Okay, and corresponding to this depth, we will have like, okay. So they are designated ISJC, ISLC, ISMC, Indian Standard Junior Channel Section, Indian Standard Light Channel Section. This way they are designated, and if we go to the steel table, they have given us all the details there in our steel table. Okay, for this section, this is the dimension, this is the distance of the center of gravity, this is the weight per running meter, these all the data that it's given in that steel table. If we go for design, we will be requiring that steel table, because in the design, if we are going for some beam design, some column design, we are saying that we will be using this column here, and we are saying that we are using this T beam for the purpose of a beam here, then we have to go there and we have to take these properties from that steel table. Okay, so this is a box section, so this will be used in columns. Okay, used in columns. So this is the box section this way. Then this is not, we know already. I guess if you remember, this was our universal testing machine. Here we conduct the test for steel section. We have some standard material like this. This is provided this way so that we can hold it between this point and this point. It is, and then it can be held, and then we apply stress and it will elongate, and we will, okay, this was originally, it was like this. If we apply stress, it will elongate, there would be necking break, and we will measure the yield stress, the necking deformation, what is the total strain, total percentage elongation, etc. All these properties we will measure from this tensile test. I hope you remember it. We will not go through again. I hope you also remember the stress strain curve. It is very important. What is proportional limit, what is elastic limit, it is very important. Okay, what is necking, it is very important. I hope you remember this. If you do not remember, please tell me now or later. I do not want to repeat it because we have already studied it. So okay, so that's it. For the winding up of introductory part, after this we will go for some numericals of steel design. Okay, so these few points that we have discussed, they are very important from this MCQ type complex examinations. Please try to remember them. Okay, note them down, try to remember them, so they are always asked. Okay, what are the different percentages of carbon in different types of steel, what we have in stainless steel, what is the modulus of elasticity of steel, okay, what is the thermal coefficient of steel, what is the thermal coefficient of concrete, okay, why we use steel as a reinforcing part in concrete, okay, these type of things are always used. Please try to remember those things. Okay, there is also LB is HB, okay, which one is light, which one is heavier. Okay, this is very easy, right? L is for light, H is for heavy. That thing is always asked. So please try to remember them.